So we have mass to mole conversion this time. So in mass to mole conversion, this is a two-step process again. And step 1 will always be calculating for the molar mass. So this is the same as the mole to mass conversion. We really need to have the accurate value for our molar mass. So molar mass is always the first step, and we have to make sure that we calculate it properly. After that, step 2 will be, this time we're going to get the given, and that given mass will be divided by the molar mass from step 1. So we're going to get the given first, and then we put the molar mass below it so that it will be divided, so that we can get the final unit of our problem, which is in moles. So the final unit has to be in moles. So again, calculate for the molar mass and then divide the given by that molar mass. To illustrate that these steps, let's now look into some sample problems here. So we're going to do sample problem 1 first, and then we'll also do sample problem number 2 together. Now, let's start with number 1. How many moles are there in 2.65 grams of P2O5? So our given is already in grams. So we began with mass, and then the question is how many moles. So therefore, we're converting this to mole. So to organize our solution, let's do it step by step first. Step 1, we calculate for the molar mass of our substance, which is P2O5. And we know that P2O5 contains P and O, and from the subscripts themselves, we can tell that there are 2 P and 5 oxygen. And then after that, we are going to multiply this by the atomic masses again of each element that is found on the periodic table. So on the periodic table, P has an atomic mass of around 30.974, and oxygen will have it at 16.00. Okay? Now we are ready to calculate that in the calculator. So we have 2 times 30.974, then we have 61.948, and then we have 16 times 5, then we get 80 for this. So let's just maintain the decimal places there. So 80 plus 61.948, then we get around 141.948. Let me just put the plus there, so to emphasize the plus again. And then we should not forget the unit for molar mass, which is grams per mole. And then we will box our molar mass to emphasize that that is what we. So after solving for the molar mass for step 1, we are now going to do step 2. And step 2 is divide the given by the molar mass, so mm molar mass from step 1. So how do we illustrate that in a solution format so that we can cancel out the units? So of course, we always begin by writing our given value. So our given value is 2.65. So you write that down, 2.65 with the unit grams. So the G has to be there, and then you put times. By default, you put the times there, and then you have a parenthesis in which you will have a line to separate the numerator and denominator. This time, we know that we need to divide. So therefore, this value that is 141.948 has to be placed in the denominator. So we'll place that there, 141.948. The grams should be accompanying that value. And the per mole here, the 1 mole, will now be placed on top. So it is alright to reverse your molar mass value in this way if we are dealing with mass to mole conversion. So it's alright because the molar mass becomes your conversion factor this time. So we are switching now, because in the previous conversion from mole to mass, the mole was below and then the grams was on top, because that was mole to mass. And because we're reversing this time from mass to mole, so we are reversing the placement or the position of our mole and gram. So the 1 mole is on top this time, and the grams is now placed beneath. The reason for that is so that we can cancel our gram unit. So the gram from the given and the gram from the molar mass will cancel out. Therefore, we are left with our mole unit, which is what is asked in the question. In shorthand, we can shortcut this as 2.65 times 1 mole. It's still 2.65, but the unit will now be mole. And then over, so the line here over the value 141.948. So that's how you will compress this part here into this, with no grams unit anymore, but with just the mole. And once we've compressed it, now we're ready to divide that directly in our calculator. So that's going to be 2.65 divided by 141.948 equals, so we get all these answers here, but we have so once we have plenty of answers in here, we know that we'll just pick up the 2 decimal places. So your decimal point is here, so we're going to pick 0 and then the 1 after that. But 1 is followed by 8, so the 1 will become a 2. So that's going to become 0.02. And then the unit will be just the mole and then of our substance P2O5. So of P2O5. And that is the final answer for our sample problem. Let me go to number 2 here, the second problem that we're going to discuss for today. So determine the number of moles, so we're asked for the moles again, in 45.5 grams of MgSO4. So let's do step 1 first, which is to calculate for the molar mass of MgSO4. From your end, please also calculate MgSO4 as I calculate this, so we can compare if we get the same molar mass. So the elements that we have here are Mg, S, and oxygen. We have 1 Mg, because there's no subscript in there, 1 S, and we have 4 oxygen. And then we're going to multiply this to the atomic masses found in the periodic table. So magnesium is 24.305, sulfur is 32.06, and oxygen is just your 16. And then we're going to multiply that. So this is just times 1, so it will just be the same value. Same with sulfur. And then for 4 times 16, that will be 64. We add all the molar masses again. So let's add that. We have 24.305 plus 32.06 plus 64. So we have 120.365. And we should not forget again that the unit for molar mass is grams per mole. So I hope that you got more or less the same or close to the value that I'm getting here. Okay? Now let's go to step 2. So step 2 now is we're going to divide. So I'll just put the word divide there, the same process as the previous problem. So we divide the given by the molar mass. So as always, we write the given first, which is 45.5 grams. We multiply it to our molar mass value, but the 1 mole will be on top this time, and our 120.365 grams will be below it. And then we cancel the gram. After canceling the gram, we can now compress that as to 45.55 mole over 120.365. And now we're ready to input the division operation in our calculator. So that's 45.5 divided by 120.365. So we got plenty of answers. we just need 2 decimal places, so that's 0.37, but the 7 is followed by an 8, so the 7 here becomes an 8. So that's 0.38, and then the unit will be mole of MgSO4. And that is our final answer for this problem right here. Okay? So that's the whole process for converting mass to mole.